All right, once again, we are skipping ahead to lesson 9. On lesson 9, we start talking about sampling and margin of error. Sampling, when you're conducting a statistical study, is really important, um, only because it's usually virtually impossible to get data from the entire population. So, what will happen is statisticians or researchers will very often take smaller samples from the larger population and then use the results from that sample to make conclusions or to make estimates or possible estimates about the entire population. The key is that one sample is not enough. If you only take one sample from the population, that could lead to possible biased results. When you take many samples, you can have what we call a margin of error. Okay, that's a term that you may have heard before. Okay, the margin of error, this is the textbook definition here, the maximum expected difference between the estimated value and the actual value. Okay, so that's when you see the plus and minus certain percentages when you look at political polls and stuff. In other words, the actual value is somewhere within that interval. Okay, to find the margin of error in this class, we're going to find the margin of error by taking this 2 times the standard deviation. 2 times the standard deviation. And we're going to go above and below our estimated value. All right, so the way we interpret it is that the interval will capture the actual value 95% of the time. So not 100% of the time, but pretty darn close. All right. So if we increase our percentage, if we were to increase this percentage here, so if we wanted to capture the actual value, say 98% of the time, rather than 95% of the time, we would have to increase our margin of error. If we decreased our percentage, we would decrease the margin of error. Margin of error also depends on the sample size. So the larger your sample size is, the closer your estimate will be to the actual value. In other words, you'll have a decreased margin of error. And the smaller your sample size is, the larger your margin of error is. So with that in mind, let's take a look at our examples today, which are similar to the ones that you'll see on your cool down. So number 1, Mike gathers a random sample of 50 students from his high school and asks them if they would be willing to start the school year 2 weeks earlier than they normally do. 40 of the students agree that this is a good idea. So Mike goes to the principal and says exactly 80%, 40 out of 50, exactly 80% of the students at this school think it's a good idea to start the school year 2 weeks earlier than usual. What is wrong with this statement? Well, there's many things wrong with the statement. The first thing is he only took one sample. Okay? Mike only took one sample of 50 students. Okay? This sample, if you only take one sample, it could lead to biased results. So this sample could lead to biased results. Okay? One sample of 50 students may not necessarily be representative of all the students at the high school. Okay? So one sample of 50 students may not be representative of all students at the high school. Okay? Hope you understand what I mean by that. Okay? If we want to get an idea of what all students think, just simply taking one sample of 50 students is not going to give us a good idea of what all students think. Think about it here at AL. Here at AL, we have between 1,200 and 1,500 students. So if I wanted to do this survey, if I only surveyed 50 of you, 50 out of 1,500 or 50 out of 1,200 is a very small percentage of the entire school population. So I would need to take a bigger sample or take more samples in order to get better results. So that's number one. Number two, Mike decides to collect more data. He then reports that the percentage of students at his high school who think they should start the school year 2 weeks earlier than usual is 80% with a margin of error of 5%. What does this mean? Okay, so margin of error of 5%. What that means, and I'll type this in here so you can see. Margin of error of 5% means 80%. 80% plus and minus 5%. So 80% plus and minus 5%. That's going to be anywhere between, that's going to be somewhere between 75% and 85%. Because if I subtract 5, I get 75. If I add 5, I get 85. So my margin of error is between 75% and 85%. So if we go back to our lesson notes, okay, if we go back to our lesson notes, we see the actual value is somewhere within that interval. So in the context of this question, okay, this would mean that the actual percentage of students at this high school who think they should start the school year 2 weeks earlier than usual. So the actual percentage is between 75% and 85%. So somewhere within that interval is the actual percentage of students who think that that's a good idea. That is what margin of error means in context. So this right here, whoops, is your answer to number 2. And that is it for lesson 9.